Hi everyone, the title of our work is An Intelligent Multimodal Dictionary for Chinese Character Learning. We are from Advanced Innovation Center for Future Education of Beijing Normal University. Language learning is a promising market in education in China. Here is 2022 Q1 Top 5 Advertising Education Apps in China. And the data is from AppGrowing. We find that top 2 apps are about language learning. NetEase Youdao Dictionary is a popular digital dictionary for all ages, supporting translation in 41 languages. And the iHuman Chinese, ranked secondly, is designed for young children to master 1,300 common Chinese characters, which indicates that the Chinese character learning topic and the digital dictionary tool are popular and acceptable. Our work is also targeting at this market, and we are looking for industry partners. Please contact us if you are interested in our work. Now, let me introduce our work in details. As we know that Chinese character learning is always a challenging task, due to the difficulties of recognizing single character, understanding its multiple meanings, making appropriate phrases, and forming long-term memories. For instance, these 5 characters share the same pronunciation mu, with similar structure and radical. However, they have totally different meanings. Take the last 2 for example. This one has 4 definitions correlated with scream, such as the veil of net, curtain, and scene, while the next one has 2 definitions, with one original meaning as dusk, and also an extended meaning to describe late. To learn Chinese characters, Chinese dictionary is an efficient and useful tool. This is the user interface of the digital version of the most popular Chinese dictionary, Xinhua Dictionary. When we search for a character, the searching results mainly contains pinyin, glyph information, and multiple definitions. Pinyin is an official romanization system for pronunciation, and the glyph information refers to character structure, radical like semantic or phonetic component, and also number and sequence of strokes. Then definitions are the statement of characters' meanings in different contexts using simple but abstract description. Also, there are several example phrases shown. Using the dictionary, learners could obtain the necessary information of the individual character, as well as the commonly used phrases. However, it is still difficult for learners to get a quick understanding and form long-term retention of all the characters' information, especially the characters' multiple and ambiguous definitions. Also, the current digital Chinese dictionary has not given full play to its advantage. While we found previous studies indicate that images are appropriate for representing abstract scenario and unusual objects. According to the dual coding theory, the verbal and visual dual representation could enhance learners' memory, especially when word and the image are strongly associated with each other. So based on that, we design and implement an intelligent Chinese dictionary featured with dual coding representation. To be specific, each definition of the character could be queried to show its image representation, to provide learners with definitions in both verbal and visual way. Besides, since most Chinese characters have their unique historical evolving process, we also provide images to show the evolving process and the correspondent macro lecture videos for extended learning. In the evolving process of a character, there are 5 major chronologically formed scripts that are still used today. They are seal script, clerical script, cursive script, running script, and regular script. The original script is pictorial and may reflect the visual meaning from the perspective of character formation, such as character fire in this example. This picture is from one of our previous work. Here is the block diagram of our intelligent multimodal dictionary. The dictionary supports 2 types of retrieval functions. This part is cross-modal retrieval module, and the rest of the framework is multimodal information search module. The dashed line is query flow, and the solid line is results flow. The system supports text and image of printed character as input, and text, image, and video as output. The input supports either typing a character or uploading an image of the printed character. In case learner encounters with unknown character or has difficulty with pinyin, if they choose image input, we would use the optical character recognition (OCR) service to extract the queried character from the image. The output in Multimodal Information Search module contains text information from Xinhua Dictionary, images from Involvement Database, and videos from Macrolecture Database. And here is the interactive image representation for each text definition, empowered by cross-modal retrieval. Let's look into the multimodal information search. First is text output. With the typed or recognized query character, the system queries the Xinhua Dictionary API for characters' basic information, including pinyin, glyph information, and definitions. They are basic information of a character from current using dictionaries. Second is image output. For the character involving process, we build a dedicated database to store the image collections of characters in 5 chronologically formed scripts from calligraphy works. Here are some examples of characters involving process. The last column is the original and pictorial script, and gradually it evolved to the current commonly used one. The origin is supposed to help learners have a deeper understanding of the character's glyph, including how it looks like back to the formation of the character, and its correlation with the character's definitions. Also, the presentation of the involving images helps to bridge and smooth the transition between the original form and the regular one. Third is video output. We also built another database for 15 characters by manually recording 1 to 2 minute macro lectures to further explain from the historical perspective. The macro lectures analyze characters' glyph, original meanings, shape changes during the historical process, and its current usages in phrases. This is the macro lecture for character 之。
之是一个会意字，也就是通过汉字组合进行释义。我们在实际这些汉字时需要一定的想象力。在3000多年的汉字发展中，之字的字形经过演变，有多种写法，比如篆书、隶书、草书、行书、楷书，以及我们目前通用的简体字。追本溯源，让我们回到造字之初，去探寻之字的本意吧。从简体字到小篆，再到经文，之字的本意一目了然。 即手持一支竹，本意为一支竹，后来引申为量词，比如一支笔、一支队伍、一支歌等，还引申为分支、支撑、支持、支付等。
And that's all for the multimodal information search module. Then we move on to the cross-modal retrieval part. Based on the text search results from the previous step, the system supports learner clicking on each text definition to query its image definition. Here is the schematic diagram of the process. In this example, there are 3 commonly used definitions of character yuan. Each definition could be slipped into a description and several example phrases. We take the description as well as every single example phrase as query strings. The cross-modal retrieval mechanism firstly extracts each text feature by text encoder. With the text features, it searches the image features with maximum cosine similarity in the cross-modal database. After that, the image from text-image pairs with the maximum similarity would be selected as the image definition. It is worth to mention that the image features are extracted by the image encoder and stored in the database offline in advance. This retrieval mechanism is supposed to give each definition an image representation and help to tell the differences from each other. In practice, the text and image features are extracted by encoders from the large-scale multimodal pre-trained model BRIEFO, which means bridging vision and language. Here is an illustration of the model structure from its paper Wenlan. To be specific, BRIEFO is a 2-tower training framework consisting of these 2 replaceable image and the text encoders. They are connected by info NCE loss in the training process, and its training strategy is based on cross-model contrastive learning algorithm. After the pre-training, the 2 encoders could work independently and provide APIs that we used to extract features. The image encoder is based on a vision model, and the text encoder is based on the Chinese pre-trained version of a language model. Both of them are followed by self-attention block and multi-layer perception (MLP) block to project features into the same cross-modal space. That's why we can do the cross-modal retrieval. Compared with single language or vision model, this multimodal model is learned from image-text pairs crawled from web. In Wenlan version 2, the amount of training data has been up to 650 million, and the wide coverage of topics and scenarios is rationally enough for our dictionary retrieval design. It is also worth to mention that since they are crawled from the websites, they are weakly correlated with each other. As the example shown in their paper, the text does not always exactly describe the specific objects in the picture, but the extended meaning behind it. That would be an advantage for us to take in our dictionary to catch the abstract concept of the definitions. For the current performance of the model, they have tested the model on cross-modal text-to-image retrieval task on a Chinese dataset, AICICC. The pre-trained and fine-tuned model achieves much better results than the direct training one for all evaluation metrics, which indicates that the pre-training is useful and the fine-tuning would help to improve the performance. Besides, there are still a lot of room for improvement of the direct training model. Also, we could consider to take the recall at 10 results for our dictionary for better performance. Finally is the user interface part. A mini program on WeChat of the dictionary has been developed. It could be accessed through WeChat without downloading. Learners could type the query character here and press searching. Then its basic information, text definitions, involving process image, and macro lecture video will show up. Learners could click on each text definition to see image definition. Right here, the learner clicked the sixth definition, which means put the watermelon into the cold water. Then the vivid image of the description shows up. Also, the learner could play the macro lecture for extended learning. For time reason, I will not finish playing it. Finally, let's conclude how our intelligence system helps the Chinese character learning. Firstly, through the cross-modal retrieval, interactive image representation for each text definition is designed to offer easy understanding of characters' multiple meanings and help to enhance their memory. Secondly, in multimodal information search, a dedicated database of 15 characters is designed to provide learners with a deeper understanding of the character's glyph and its correlation with its definitions. The database contains the image collection of characters' historical involving process and manually recorded 1 to 2 minute macro lectures for extended learning. That's how our intelligence system is designed to smooth the learner's path to acquire Chinese characters. In the future work, we would constantly enlarge the image and video database to cover more basic Chinese characters. Besides, as we mentioned before, the text-to-image retrieval recall of the cross-modal pre-trained model needs further improvement. There are several ways, such as taking recall at 10 results to improve the performance, or building up the user's feedback mechanism to collect the inaccurate image definitions, and collect good cases for model fine-tuning. What's more, the images for cross-modal retrieval should also be collected from online resources, and only image URL feature pairs are stored locally with a regularly validation checking. On the hands of usability study, we are also planning on it and did some preliminary work. We built an experimental platform where we provide character learning material, including text definition, image definition, macro lecture, summary page, and self-test questions. When learners are asked which part is the most useful, the image definition gains the most votes, of 32%. And macro lecture is ranked secondly with 29%, which indicated that learners are willing to accept the multimodal material we provided. We will be further working on it to get more detailed user feedback and statistics. That's all for the present here. Please contact us if you are interested in our work. Thanks a lot.